Good afternoon. I'm going to introduce you guys to your next breakout session and speakers. This session is an introduction to FME, which stands for Feature Manipulation Engine. The description of this lecture is an introduction to Safe Software's ELT tool, FME. This session demonstrates ways that ODOT is leveraging this tool today and how your data management and processing can be made easier. I have a few gentlemen to introduce to you. The first one is Tom McCree. Tom McCree is a software development architect with over 20 years experience, as well as expertise in pavement management, linear referencing systems, temporal networks, and spatial technologies. Next we have Atia Kalaska. He is a quality assurance specialist for Division of Information Technology. He has expertise in implementing various phases of testing across IT projects with execution of manual and automated testing. And then we have Cody Wade. Cody is a GIMS database administrator for District 1 as a transportation asset management coordinator with over 10 years experience as a subject matter expert in asset management, data analyst, and spatial technologies. Well,
I'm going to start. My name is Tom, as you said. I'm going to give just a brief FME overview, and I'm hoping to get to a real quick example. Are there FME users in the room today? A couple? Okay. Are there Esri ArcMap users in the room today? Okay. One of the things that I do want to talk about today is kind of a juxtaposition of those two tools, because there is some overlap, but there's also some places where one tool you might consider over the other. All right, so what is FME? We're using the desktop version of the software, and it's essentially described itself as an ETL tool. ETL stands for Extract, Transform, Load. Essentially what this means is we're going to take some data in some format. Someone hands you some data. You're going to do some manipulation to it and then write it out to another data source, do some sort of report with it, do some type of validation, some sort of work with that data. And it's designed to be, a very generic tool from that perspective. But it can do a lot more. We use it heavily for reporting, which Cody's going to cover. We can do spatial analysis with it, which is a real differentiator as far as ETL goes. It does data validation, or at least we use it for data validation, and we're using it quite heavy right now to validate our RIMS spatial data for our road inventory group. And interestingly, it also has another component called FME server, which allows you to actually take workflows that you build, upload that to a server, and then be able to execute those workflows remotely through a REST API. Now, this can be really powerful. We're just starting to scratch the surface with this, but an example of where we're considering using this type of thing would be, for example, we get pavement condition rating data that comes in from the field, and the pavement department would be able to take their spreadsheet, maybe just drop it into a folder or upload it through a web form, and it would go ahead and it would execute that FME workflow that you built in FME desktop, do all of the work, send them back a report, automated emails, whatever type of workflow that you want to do, and be able to analyze, does my data have any error? And then they could also optionally say, go ahead and insert this into our Oracle database. So it's a pretty powerful feature that we're also looking to leverage as well. As far as FME versus other tools, I find it that it's really simple to use from a conceptual standpoint. ETL is almost always broken down into 3 steps. You read the data, you do something with it, and then you optionally write it out somewhere. This metaphor is really carried through in FME very well, because there's really only 3 types of objects in the system. I'm trying to read something from a database, I'm going to write it to a database or a spreadsheet or a text file or whatever, and I want to do something like reformat the data or take a flat file and turn it into a one-to-many relationship. The first letter in the name of FME is feature, and how many of you know what a feature is? So we're going to talk about features a little bit. Okay. So a feature is kind of a GIS, and I think it actually originated from Esri. They have this concept of a feature class, and very simply, a feature class is a data set. It's a table of data. In Esri, features need to have certain rules that are met. For example, you have to have a unique object ID, and you need to have, generally you need to have some sort of geometry. What is really nice about FME is it doesn't care. You don't have to think about, is this really a feature? Because in FME, every bit of data is a feature, and if you happen to have geometry along for the ride, it'll happily go ahead and allow you to do something with that. So I only call this out because it's one of these issues that I find cumbersome when I'm working with Esri. As far as spatial ETL, spatial data and geometry is a first-class citizen of all data. So there are probably over 100 different transformers that you can do. So most of the types of things that you'd be able to do in Esri, you can find a way to do in this tool as well. It also has linear referencing support, but it's a little bit hidden. If you go to FME and you start researching, how do I do linear referencing? You're not going to find a whole lot on it. You have to actually sort of trick the system out, and that's the example that I want to get to today. By the way, is linear referencing a term we all know here? How many of you know what linear referencing is? Okay, a few of you. I'll come back to it and we'll talk about it. And then for database people in here, it's database optimized. Its readers and writers all have its own separate driver implementation. So for example, if you're reading Oracle data or SQL Server, it batch reads and writes that data, so we find it to be not as good as your built-in tools that are non-transactional. Everything that FME does is transactional and performing a transaction, but it's very efficient from that standpoint. It doesn't write records one at a time. Even though you think you're processing one at a time, you can set batch sizes and lump these writes to your database and get pretty good performance out of it. I throw that out there for any of the database people. I see a couple of you guys here. All right, I'm not going to dwell on this, but FME versus ArcGIS. So ArcGIS can do ETL type work, and again, we're really talking about, most of the time when we think about ETL, we're going to take data, we're going to do something with it, and we're probably going to load it somewhere. At least I think that's what most people think. It's like, hey, I want to take this data and I want to move it to a database, or I want to publish it somewhere. And Esri, of course, can do that, but it's not as focused as what FME is. FME, you just basically drop your writer in there, and whatever's coming out of it will either create the table and write it, or it'll use an existing table for you. FME doesn't do line work, so if you're looking to do line work or model, our roadway inventory, this would not be the tool. However, like ArcMap, it does analysis very well, and it of course does ETL very well. I'll just call this out because I kind of mentioned it earlier. There's no special connectors that you need to be able to talk to data sources like there is in Esri. So for example, in Esri, you need SDE connections for those of you who are Esri people to be able to talk to a database, right? You have to go and create this separate SDE file. You don't need that at all with FME. FME just uses the native JDBC drivers, just like if you were using Aqua Data Studio for you IT people, the exact same drivers that you have installed on your laptop to talk to Oracle, SQL Server, whatever. It will use those drivers, and there's no extra layer that you need in between that. However, if you have Esri-based spatial data and you want to talk to it through the SDE API, FME will support it. So one of the things that I think is good about FME as well is it has support to be able to use SDE connections to do things like talk to file geodatabases, etc. Okay. All right, so what can we do with it? Let's come back to linear referencing for a minute. I think from an ODOT perspective, one of the most useful things that we can ever do with the data is an overlay. I've been in and out of ODOT since 2000, and I can tell you that taking data and mashing it together, combining it, that's based on log points, is a real common activity. So linear referencing. Linear referencing is that data that you would see, for example, in Ellis, where it has a route ID, often called an NLF ID. Is that a familiar term? So like Interstate 70. And you have a begin measure and an end measure, like 0 to 10, right? And I think we mostly all know what that means, right? That's In Franklin County, Interstate 70 at log point 0 is the beginning of the route in Franklin County to mile marker 10, right? And we get this data all the time. And someone will come and they'll say, well, hey, I've got this data that's got pavement condition on it. And I've got this data over here that's an Ellis segment. And I would really like to be able to take this Ellis data and this PCR data and I want to combine it, all right? So what does this data combining look like? Well, here's a real simple example. So I have a data set 1 and a data set 2. And it's got some measures on it. And this data set 2 has some completely different measures, right? But they definitely overlap, right? We can take these two data sets, one has functional class on it and the other has lanes, and we could take it and we could combine it together to look like this, right? And at this point we could do something useful with it, right? Because now I have lanes and functional class mixed together, right? So that the two data sets are consistent. This right here is what we would call a finest partition of the data set. And a finest partition is where we take the set of all points in this data set and the set of all points in this, and we break the data on the opposite data set's log points, right? So this is true, right? 0 to 5, we have 4 lanes, and we also have major, right? But now I had to break it again from 5 to 10, and it's still the same value. And then we get 2 lanes from 12 to 15, right? So if all of the breaks that are in this list were in each of these tables, it'd be easy to combine the data, right? Because I could just say, match on this NLFID, begin measure, end measure, and they would combine. Okay? All right, so this is something that happens a lot. At least it happens a lot in the department that I work in, right? And FME makes this pretty simple to do. Now for you Esri people out there, if I handed you a spreadsheet with this data in and there's no geometry involved, how would you do this?
I try to use the linear referencing tools that come with the ArcGIS, right click.
What would you do about the geometry? How would you do an overlay?
Well, you'd have to write them out to spatial separately, and then you could combine them after the fact.
Right, so you need a spatial data set, right? And spatial means that we have the actual line work, right? We have the shape of US 23 in our data, and then we would take them and we would apply that geometry based on cutting off these measures, right? And then we would take that geometry and we'd be able to lay it on top of each other, and where the attributes shift, we'd be able to make this data set here, right? All right, so that's always drove me crazy. That's a really, I find it to be a really painful way to do it when all the information that you need is already right here. Okay, so I know I'm running out of my time already. So let me give you a really quick example of how you do this in FME. Let's take geometry out of the equation, right? Geometry has X, Y, possibly elevation, right? X, Y being longitude, latitude. And then we have an optional elevation dimension. And then we also have, in the extended definition of GIS, we actually can carry a measure on the vertices of the geometry. All right, and that's what allows that overlay to happen, because these tools, including FME, take the geometries, compare them to each other, and say, yeah, we're topologically coincident. We're on top of each other, so we're related. Now, additionally, we want to be able to relate the route together too. So if we have two duplicate geometries but different route IDs, we wouldn't necessarily want to combine them, right? All right. So within FME, this example that I have is out on GitHub for you to download. It's at the very end. I wanted to have something for people to come away with and play around with. I'm basically implementing a set of rules, but the rules here are going to force me to do an overlay to analyze the data. So let's just look real quick at what it takes to do this in FME, because those of you who do this type of work may find this useful after the fact. I'm trying to hurry. So here I have a spreadsheet, and I have this county data here, which just has some from-to measures and one attribute called county, and it's got two routes, Interstate 70 and Interstate 71. Then I have another tab here, I call it mileage allocation because that's what I pulled it from. And it has an additional attribute, oops, sorry. It has an additional attribute of P to say that this is a primary route, S means it's secondary, okay? And if I was trying to implement this rule where I said, hey, for this county data, I want to verify that this county data is covered in the mileage allocation data, but only if it's primary data, right? So if I were to take the county data and I were to overlay it with the mileage allocation data, anywhere where county wasn't present but mileage allocation was and the value was primary, I would have valid data, right? And anywhere where it doesn't, I don't have valid data. So essentially, I just want to combine the attributes, all right? All right. So this is FME. And just real quickly, because I know I'm running out of time, just to walk through the first bit of this. This is reading that county tab, so this is a reader. This is a reader. And then the special trick that I wanted to kind of talk about with FME is we actually do have geometry in those spreadsheets. It's the measures, right? It's a one-dimensional geometry. So if we say that the begin measure, and I set that to the x vertice, and so log 0.0 would be 0, 0, and log 0.5 is 5, 0, what I've made is a line geometry, right? In fact, a really simple line, a very efficient geometry line, because to topologically compare two horizontal lines is really fast compared to a really complicated piece of geometry, you know, like our road network, right, with thousands of vertices. So one, you get big efficiency out of this, okay? So this transformer right here is a custom transformer that's available to everyone who's an ODOT employee or who's in the ODOT network. We have it out on the network for people to use that basically combines a bunch of transformers together to extract the measure from, measure to value into a from to linear line, right? So this says take measure from and measure to and make it x1, y1, x2, y2, and that's your geometry. So now it's carrying geometry without having to go out and hit the county network or some other spatial data somewhere, okay? We've made a real simple linear network there. I did the same thing with mileage allocation. So now I've got two data sets that are carrying geometry that are comparable. However, Interstate 70 has a 0 to 5. Interstate 71 has a 0 to 5. Interstate 73 has a 0 to 5, right? So now all of a sudden, all of our geometries are laying on top of each other in one single line, right? Which isn't going to cut it for an overlay. So typically with an overlay, there's some other grouping data that's within the data set that you want to join on. And that's where this line-on-line overlay tool, the thing that does all the magic, comes into play. So here, I set my group by value to NLF ID, which is my route ID. Now, it will only take Interstate 70 data from both data sets. You'll say, if you're Interstate 70 and you're Interstate 70, I'm going to go ahead and compare your geometries. So now it can do an overlay of that data without having to worry about it walking on other geometries that are present. Okay? And the rest of this is just really implementing some basic fundamental FME. I know a lot of you don't know it, so just a quick plug. FME's training, their stuff on their website is awesome. It's how I learned it. I just went on their website and started watching a couple of their videos. They have a whole handbook, they have examples for you to work through. This is an example that we'll probably do a brown bag lunch on and we'll dig into more detail. But prior to that, I would highly recommend if you want to learn how to do some work with FME, and this, again, it's linked out on GitHub. You can download this and play around with the data inputs and see what happens. You know, it's available, but FME to learn, there's a lot of resources on their website to learn it. All right, I think that's all I have time for. So I will hand this over to Aditya.
Now it's on to a couple of my minutes. I'm like, what should I start with? Okay. I don't want to take much of your time, but I'll just keep it simple. So me being a QA, I deal with a lot of validations. FME is a tool which is perfectly used for data validations when you deal with spreadsheets, databases, different databases. I know talks Tom spoke about linear data, but I don't use FME just for linear data. I use for finance, I just use static FME for finance. So it's not just linear, it's any data which has spreadsheets or databases. So more or less that's how on a high level. But the reason why I started to have interest in speaking up today is to just give you guys some confidence that yes, you can do it. It was last year when I started working on FME, and the first time when I saw FME, it was, I would say, at least 20 times much worse than this when I was working with Tom and Lavanya. They saw this is FME, I'm like, no, I can't deal with this. This is totally new. I just came to you guys to help me with what I'm doing right now. You guys are giving me a new problem. No. Then I went back to my desk and I was looking, okay, this is something which is really powerful. Then what I did was, which is the wrong way, I started looking at the results and I didn't see what I was doing and I ended up going nowhere. Then I took a step back. Then I know what I'm supposed to do. Then I wrote down on the paper. So, okay, this is how you do it in your brain. I forget about FME, that's how you actually solve the problem. Then I put that solution on FME and came to know what different transformers you can use, what are different inputs and what should be your outputs. That's how I learned. I didn't take any training, trust me. I'm not saying you shouldn't take training. That's how you start. That's how you get your training material. That's how you know what are the different transformers, what are the different inputs. But you should have real-time, step-by-step experience. Then you get to know how you use FME. Because it looks simple, it is very powerful, but you have to have your hands-on experience in order to work on FME. So that's the first slide where it says more or less how you get to know FME. Now, coming from a QA point of view, as I've said, I deal with more of data validations, which requires multiple data sets. So the one thing very important about FME is you can reduce manual testing. What I usually do is I just create one FME, even though if it's not at the end of the project, at the beginning I just create FME, and if there are any changes coming up in the project, I just change those inputs. Because you have your logic built, all you do is change your inputs so that you don't waste your time doing your repetitive manual test. And as Tom was saying about server, that's when you actually use the workflow to be automated. You can just maybe use it as a nightly batch, just to make sure that the data validations are working fine. So, I have a couple more minutes. So, what I wanted to say is, FME is not just for linear or spatial data. It can be used for any data where you're doing validations, respective linear, spatial, any type of data. So more or less, you just need to know what you're doing. Then you get to know, okay, this is the transformer. I mean, I haven't really gone through all the training materials, but what I usually do as of now is, I know what I'm doing and I just Google it. Trust me, I just Google it. I know, okay, to do this, which transformer should I use? I get the name of the transformer. I get to know what the transformer does. Then I play around. Then I get to the end result. Tom might do that in 1 hour. I might do it in 2 days. I'm okay with that. And then I admit it. Trust me. It's not just Tom. Tom, Lavanya, whoever is from the spec services, I know it. I don't care. I mean, all I care is I'm learning stuff. The end result is same. Trust me. He might be doing in 1 day. I might be doing 2 days, but I'm doing it, right? So that's what I was thought of sharing with you guys, that it is something which everyone can do. You just need to know the basics, and you have to keep some initial efforts to get to know what exactly is FME. So that's about it. It's pretty simple. And this is the most basic FME workflow I've written. So this is where and this is what Tom was saying, linear referencing data. This is not financial or something. So all you're doing is you're just validating the duplicates and overlapping segments. So in order for me to do that, I'll just take a data set, and you have different filters to do your duplicates. So this is it's a straightforward duplicate filter, and you keep your conditions in it. Okay, what are the key fields? Based on that, I can make 2 different records duplicate. So it's a straightforward duplicate filter. And the most powerful transformer is the tester. That's where you write your if conditions. If A, B, C, then the result is C. So that's the transformer I use to make sure that there are no overlapping segments. And if it's a successful if condition, go to one spreadsheet. If it's a false condition, go to another spreadsheet. So in that case, I have my output listed out all the good results and all the bad results. So this is the most basic workflow I've created, but then this is not it. You can play around with FME a lot. You just need to know, as I keep saying, you just need to know what you're doing. Write down on a paper. That's what I would do, and I'm assuming Lavanya and Tom does the same too. But that's the starting point. Write down on the paper what you're doing, what is your workflow. Then you take that idea, Google yourself what transformer makes you go with that process, and that's how you do it. That's all I have for now.
So in previous slide, once you run this workflow, I'm assuming that you shouldn't be seeing any records that come to duplicate, and as well as to the overlapping one.
I mean, if you have duplicates, you would.
No, I meant to say, what you're trying to validate is that incoming source data do not carry any duplicates, nor overlapping, correct?
So what happens is, if this data set has duplicates, those duplicates will be gone here.
Correct.
And the good data would be moving forward with the further validation.
Right, okay.
Is that clear?
Yeah, I meant to say, if you see records under the duplicates, or if you see records under that overlapping, you mean to say that you
That is bad data. You have to look into it.
Okay.
You have to do your further analysis of why it is duplicate and why it's an overlapping segment.
Okay.
So those are your bad outputs. This would be your successful non-duplicate, non-overlapping segments. Good? Okay, now I hand over to Corey.
From the slide, I was going to be more or less just kind of describing from a district perspective what applications I've been utilizing it for and so forth. Again, like we talked about, everyone hears is data. Yeah, you got to know what data first, write down what data you're going to be using, what's your outcome you want, and then you can start these transformers, these applications, and so forth. For District 1, we partnered with District 2, I believe back 2010 to 2011. We made, I think, the initial purchase for this state for ODOT, just a couple of licenses for ourselves. It was piloting and testing it out ourselves. Maybe others have made purchase with this as well. Now I know kind of a bulk contract, I think, or purchase with this application. So with that, there's multiple different functions that the district wanted to use it for. And sorry for being grainy. I wanted to give you guys the detail here, but I can try to describe this a little more in depth here. But overall, with the district is, yeah, we have many different tools. Tableau came out, Power BI, all these different tools are out there. If you know SQL, of course, you can do SQL statements and all this and that. Excel. Well, out in our district, a lot of our SQL users are GQL users. As that time, a lot of their reports that they don't want anyone else to update. So who's to update, who's going to fix it, and so forth. Well, what has happened, the district wanted to have a report updated on a nightly basis, make sure it's always reported and so forth. Well, yeah, we can use all these different tools to do so. There's just different times requesting. If we did our own Excel with SQL statements, on one table we had to request a permission for all users to get to see that data with some of the information inside of it. So being able to use FME, I was able to kind of eliminate that obstacle for requesting permission, but bring all the data. So one example is this one here. Our CPA and our planner wanted to know where's all of our active projects. Now that kind of adapted from, it was first primarily where's all of our active projects that we have workers on. That goes from design, what ones are we working in and so forth, where we adding funding to the part of construction where we actually hit substantial work completed, where the majority of our staff is back off and we're back to working to, you have them for different things. So this report here, I know there's a lot of things going on here. At first it was one report. Well, that was only a small group of data sets, actually this cluster here. Well then, now I want some Ellis dates. Now, into here, that's what this cluster is here. And all that's doing is bringing in all the data from Ellis tables of the Ellis project information. Now I filtered out, I don't want to see, let's say district. Yeah, we want to see district, but that record of district, I don't want to see it. So with this data, you know the table, it's not going to be like GQL where it's going to show you that line chart, so you gotta know that part of it. But you at least can restrict, you have a table that can have 1,000 records deep. That's just how many fields are in there. Now, at that point, I don't wanna see all 1,000, just give me 2. Okay, so at that point, that's what all those kind of entail. Overall, it runs through all the application. Now I've turned this into using it for 4 reports in our or for 5 reports for our staff here. Next slide. But so going back to this, running 3 different SQL statements, 3 different SQL warehouses at the same time. I guess it did have 5 Excel reports and as well as 1 SQL update. Now, this application here that I'm using right now, I'm also adapting into our CAD and GIS. We're doing a task there with our design, taking our design work, and I'm working with John Puente, and we have a subcommittee, have a group together trying to implement that information. Justin's in here too. See Don at the moment. But anyways, we need to know Ellis. So once the project is awarded, we want to see that information from design go into our collector platform, all the assets. So you can start off small. You start off with one simple thing. Now, instead of me creating more and more different reports and have it run on the server, I'm adapting it. Just like we do with everything else, you just adapt that. That could be a SQL statement or a Tableau if you need to go to that platform, or Power BI. So at that point, again, overall, knowing what we wanted, but this one here, I'm pulling in our TIMS layer as well. So I want to know from TIMS, what projects do we have mapped? So I can create a hyperlink for the staff that they can click onto that and actually see the project information. So yes, I'm using table, but eventually I do get the geospatial on this. Out of that comes a report like this. Again, I do it on my desktop manually first to start it with. With the gracious of, I think with tech services, as we have the server license, I was able to publish to the server. So instead of taking my resources on my desktop, this does, if I ran it from my desktop, so if I go back a moment here, it took 19 minutes on the server. That would actually take over, I'm going to say, let's say half an hour to 45 minutes to run on my desktop itself. Now again, I'm running 4 other applications as well, trying to get those done, but this one here. So again, yes, this can be done by different other tools. This is one of those, is just a quicker tool for me to very visually see all the data come through and so to get this job completed. Another one, again, sorry for being small. If you want further detail, I'd be happy to bring it up and show you the workspace. I was kind of asked from our district, as well as talking with some of our my other counterparts, team coordinators. We all had a problem. We know we have all these assets. How many assets do we have? When's the last inspection cycle? Who inventoried it? What time did they inventory, and so forth? So we wanted a very high level report that pretty much comes up to here. So now I can filter out. Again, this is all in Excel, so yeah, eventually it'd be nice to mold this into another solution, Power BI or Tableau. But just being able to run this to a SQL database, and now I can drop into an Excel system. Where's my inspection cycle? So I can real quickly see in 2018, how many assets do we inspect? So very quickly, again, right now, that's pulling 27 tables from SQL in the warehouse itself. That's copied from collector, that I'm pretty much running this right after that copy to make sure we're getting the most up-to-date information as possible to run for this report. That application, so total, it's bringing in with the warehouse, it has duplicate entries. And what I mean there, kind of as you were saying there, every time we hit save with that collector application, it saves the record and saves an extra record if anyone else didn't know on that part. So we're keeping a log of those records. Now, currently with the warehouse, I'm bringing everything over because I know we, as the team coordinators, we also have to know, looking historically, how many times did we change it this year? How many times have we inspected over how many years? So we're not to that part, but I didn't want to exhibit that data out, but still showing up. So right now, total at that time, close to 700,000 records. So imagine that's tripled or quadrupled because of the multiple values. Being able to read all that data, filter it down from the whole data set, adding some different comments to it. So not all of them have a compliance, but we have a GA value. So what value criteria is as the asset to be non-compliant? As to the other assets, we have a non-compliant field. So I'm going through and saying, okay, this term is non-compliant. I'm relabeling that field to say compliant, as well as the GA, bringing that over, doing the calculations of the GA equals this or to this, it's not compliant. So adding those values into here very quickly just kind of brings that all together, So again, I think, Kate, as you mentioned there, is trying to take a lot of these tables, cleaning them up as you guys copy them to the warehouse. FME is another good tool. Even at that point, you can go ahead and update those in this transition. Now again, yes, if I were to run the report for staff and leave the name of the fields alone and not touch them, yeah, they're gonna be confused with a lot of the names we use. It's just how we have to operate to build our applications. So overall, that's another quick application. So let me just back this up here. So right now, this is just one asset right here. Each of these little areas, if we call them, you can make a bookmark to make sure it's clustered, disable that. So if you don't want to run that asset, you can disable it. So each of those are an asset. The next one I'm using for my staff is they want to know which ones are on the QC list, which ones need an inventory photo. I'm building an additional one that brings in more tables. So right now I only have 3 assets in this one. So right now with 3 assets, that's 14 tables. So it has also the inspection and inventory that you pulled initially. Now I have all the attachment records as well. So I don't want to create a hyperlink to an attachment that doesn't exist. So at that point, using FME, that's where a lot of this other, so this would be inventory inspection here and here. Those are the attachments. So I'm doing the filters, merging that out, cleaning it out. So I only see the hyperlink I want to see. So overall, that's, again, I can read through this, but 7, okay, 4, here. So this is taking 14 tables and 7 Excel reports. So with their collector program, the collector team has each asset did which ones are on the QC list. So if they don't meet qualification, it's on that report. I don't want to go through and have to re-justify all the work they just did. Yes, I can very easily add that in the statement, but that is official. That QC list is official list we have to go by in our district. So I just bring those in and I have it merge those together and process it through. So overall, that report kind of creates multiple different ones here for me or my district. So like right here, I have which one's being inspected this year, so I calculate that with their inspection values and put a date with it. There's a maintenance, there's a QC. Overall, my staff wants to see this as an overall for each asset. We're behind inspection cycle, which ones need maintenance. So now we know when we do our work planning functions, how to get that processed. And then lastly, now again, that was all, I think you're talking data right now, tables. Those are all geospatial data sets. I'm able to keep them still in their geospatial platform as being a point or line, or convert it from a line to point. I'm not doing these for these ones here, but overall, being able to produce that information over here, I can very easily make a new level in our web application. Here's my QC list, for my staff can see that very quickly. How much more work do we got to do? I think, so as for our district, we got a whole bunch of BMPs that we got to relook at on our 75 outlet. So overall, got a few more minutes. I'm not, there's multiple different ways of data sets, and the other one I'm talking just quick tables. The other issue we had, me and Jody talked about this. I'm still kind of periodically help out in the IT realm. No more periodically, not really at all. It's just whenever my staff can't find anyone in IT, they come to me, hey, can you reset my AD or do something of that nature? At that point, we had an issue with some of the Citrix applications. Some of the users, it just wasn't working for Site Manager. Now, in that case, we realized, talking to ECT, we had an additional profile .bat that was running that was kind of interfering with that application. So at that point, where are they all at? Well, instead of us having to go through, do a directory search, and have to open up each one, and all right, is this one in the correct profile, or is this the profile that screwed us up? You guys, I think there might be other applications, but very quickly, I just tossed this in FME and just said, hey, so the text line is pretty much that. I want to find all profile.bats. So if I would do the properties on that, I said, look in our directory for under our users, look at profile.bats if we have one. Out of that, give me that information. So that's the first thing. The next part I want to see, so it's just all, the profile.bat is just text document, just a text line. Now I want to start cleaning that up. Now we have a lot of REMs, we have things that they have to do. So I wanted to filter that, which of these profile bat is it actually running, to which ones is it just for memory for us to, check out later. So I was able to, at the very end, parse out, have a hyperlink to the profile if we wanted to remediate that or fix that. We also figured out what user that was assigned to, so some of them from construction not being able to use Site Manager, from that application. So we could figure out that user very quickly. And at that time, I could also tell which of the scripts were active and which ones were for the first for memory area. And then overall, the very last one has that whole text and that whole part of the Excel file. And I just wrote this to Excel. Again, whatever platform you want to take this from, write it to. I try to find those numbers. That's gonna sum me up here for today, but I was trying to find you the numbers on how many transformers that FME has, as to how many things it reads and how many things it writes to.
So Cody, we've been talking a lot about Excel and a lot about SQL, but there's actually over 350 data type readers and over 250 writers. So you can transform from one to the other, and they're showing one output at a time. You can actually output 3 different, 4 different, 5 different items all at once. It's actually very fast.
That's what I was trying to, since the last time I found those numbers, they've updated quite a few more, and with their company, they will have 1 to 2 people dedicated to everything that is reading and writing it to. So whatever a reader or writer that they consider it to be, if it's SQL, they have SQL experts that know how the FME is working with it. The other things I've not quite got to, so again, I kind of talked to that batch profile search. That's what we're using for our CAD GIS application. Using it first, again, looking at the ELS data. If it meets the award date, it's going to run it. Now, if it runs it, now I know I got to find the application for it to run. And where's that design file? That's where more code, more of the lines to say, look at this directory. So overall, I'm going to leave it to that. We've got a few minutes. I guess we'll leave it for question and answering.
I got a question. So on several of the slides, you talked about taking multiple existing SQL Server warehouse data tables and then merging them into a new SQL table. Where physically is this new SQL table at?
Mine is under, I give an apartment.
Is it a local copy?
It's not a local copy, it's under a GIS warehouse. And there's a D01 instance that.
So you've actually got write access to a SQL Server, enterprise SQL Server schema that you can put those in?
Yes.
Okay, because as we're talking through this, and I know you're using Excel, and you mentioned Tableau or Power BI or any other tool you want to connect to that data to report on, the data's got to be in its final state in order to produce the Excel report or the Tableau report or the Power BI report, right? And so that final state would be a database table somewhere, right? Because it's not executing that process every time.
Correct.
So I think for a lot of people, they're not going to have that level of access to create a physical database table somewhere.
There's
So
no
I think
need,
that-
though, to actually write it out to an enterprise database.
Say again?
There's no need to write any of this out to an enterprise database. That just happens to be an option because he's publishing it.
Right.
So for example.
But I mean, for folks that want to create something and publish it and distribute it, they would need.
Of course,
Right.
yeah, just like whether they used FME or any other ETL tool, they
Okay.
have to have that type of access. But by the same token, it works perfectly well locally with SQLite or a file geodatabase or Access or Excel or any other local database that you would support. So anything that we're writing to an enterprise database could just as easily be written out to a flat file if you so chose.
Okay. I think it's just an important
to
piece
your
of
point, there's
information
hundreds
for
of
people
different
to
outputs
understand.
that you can produce.
Yeah. And again, that's the outcome where I think, Rich, you really got to know, like you said there, you have to really write down what data do you, what is the goal, what is the data you need, and where's it going to go, and where's it going to be placed at. And that's where, figuring out where you want to go to. Because I know a lot of times when I first did it, I didn't have SQL access. So all I did was write it to a file geodatabase and just have it run all the time. So is it right or wrong? That's the part I think definitely with FME, sitting down and almost figure out some other protocols, because it is kind of new, I think, for a lot of divisions using not only one protocol, but still, what's the best way to do it? Anything else you want?
Questions? Any more questions?